record. Okay, so this week is week 2, okay? Week 2. And several topics here. First thing, I want to spend some time on the homework. Actually, homework, we have 15 questions, right? And we review the number 1 to number 10 in the class. And I leave the 5 questions for you guys to do it. Did you guys have opportunity to finish 15, 11 to 15? I think, yeah. If you have questions, just bring it up right now. So first thing, from question 1 to question 10, anyone still have question, concern about the question? I will provide the answer a little bit later. But if you have any question about number 1 to number 10, I will let you guys go revisit the video part. Okay. So we will move on Q11 to Q15. Okay. Let's go that one first. So if you're done, and we'll move a little bit faster. If you or you guys feel challenging, I will take a little bit longer time to explain it. Makes sense? Is reasonable? It makes sense? All right, so let's move on this part. All right. I know sometimes I provide answers here first, but you can check your answers here. I put the answer at the bottom here. You guys can see it. All right. You guys can see it, right? Okay. Let's see the first number 11. I need someone. Jason, can you help me to read this paper first? These kinds of question first.
Wait, me?
Yep.
A pteromono consists of 4 squares connected along their edges. There are 5 possible pteromono shapes, I, O, L, T, and S, shown below, which can be rotated or flipped over. These 3 pteromonos are used to completely cover a 3x4 rectangle. At least one of the tiles is an S. What are the other tiles?
So first, yeah, easy part, right? So first thing, so this is a least part. All right, they made just like each of the tarot means 4, right? Like each of them made of 4 of the squares. They have so many different kinds of potential shape. And right now you have this part. This part is 3x4. 3x4, 3 times 4. So you need 3 different kinds of 4 blocks, right? One of them. So need 3 of the piece. One of them already designed, say it's S. One of them is already S. All right. So if they fail with S, what's the other 2, right? What are the other 2 tiles? So the other 2 tiles, we can put in first. We can put this S first, like this one, right? We can find one. We can quickly fill anywhere, but you need to fit in. Fit in something like say here. So we just suppose S is fill this 4. Okay, where this 4. So what's the rest part? Can fill in. So you have been here or being here. Right? So this 4. You take this 4. The rest will be this 4. So looks like 2L, right? The answer is here. Make sense? So that's the easy one. Or potentially you have different kinds of idea. So suppose your S is right here. Let's put it right here, right? So you fill the rest, or you have to connect together, right? Right. Also 12. What about anyone have different idea? What about put the S here? Is it okay? Fill S is like here? No, right? Because this is only one, right? So one you cannot connect together. Can you put the right here? The same, only one, right? Not good. It's because of each 4 block, at least the rest 4 is should be connect together. So just like say, if you fill here, you have this one. I'm sorry, 3, 4, 1, 3, 4 here. Like you don't include this part. 12. The answer is C. The answer is C. Right? Make sense? Makes sense, right? Okay. All right. I know a lot of people do. Oh, everyone do correct. That's crazy. Good. All right. Let's go number 12. Anyone have a question about 11? Anyone have a question about 11? No. Okay. Well, that's good. Easy part. Next. So this is like geometry. Geometry. Right? Geometry. I will ask someone help me. Nick, can you help me? Nicholas, can you help me read this?
The region shown below consists of 24 squares, each with side lengths 1 centimeter. What is the area in square meters of the largest circle that can fit inside the region, possibly touching the boundaries?
Okay. So let's read it here carefully. Yeah. So first sentence, the regions. Each time whenever we do these kinds of question, I think the key important things is make sure you understand this question first and what the answer you like looking for, right? So key thing. If you don't know it, just read it one more time, 3 times. Yeah, read 2 or 3 times. First time you make an impression, second time you digest it. The third one you begin to planning your kinds of skills. All right, let's look. That's look good. That's good thing to practice. Make sense? Okay, so the region made of 24 actually square. Actually, they are symmetric, right? Something like if you cut this part, looks like symmetric, right? If you can flip over, it flips upside down. So looks here, you can quickly observing this one is the center, right? So each of the side is 1 centimeter. So it means each square is 1 by 1, right? 1 by 1. What's the area? So this is the question. What's the area in square centimeters? Inside in square centimeters of the largest largest circle. Let largest circle. So you can do a lot of circles. So you can this center. You can do this circle. You can use this one like touch here, right? Kinds of circle. I didn't so perfect drawing, but can use some tools. Let me clean this one. Use some tools to make me better. The pattern. So like this kinds of drawing, right? You can do a lot of drawing circles inside, right? So you can get possibly touching the boundaries. This inside or outside? It's the boundary, possibly touching the boundary. So largest circle that can fit inside the region. So inside the region. So you cannot outside, right? You cannot here. Something like you do a circle, potentially a circle here. Partially is outside. So it's not like that, right? So should be. So here is the center, right? Here is the center. So you can see which part you can longest. You should find the biggest diameter, right? Is it try to find the biggest diameter? So looks like touch the side. This is the edge. This is the edge. So please the center. Looks like you can be here if you draw like this way. This is looks not the largest, right? See this one the largest? Looks like they can expand, still can expand a little bit here, right? You can still expand a little bit here. And here is 2, here is 2, here is 2, here is 2. It's still expanded. It looks like here. Cross over here. Looks like this one is the longest. If you expand a little bit more, it would be outside, right? So actually, this is somewhat a geometry, somewhat like you understanding what's something like here. This is the radius, and this can be radius, and this can be radius. So this one touch here, every center to the period of the circle is the same distance. So we need to find this. Actually, this one also equal here, right? Equal here. So these two radius. This is the radius, a little bit longer than 2, but not exactly 2, right? All right. So looks like this is best fit, best kind of largest circle, right? So we can see, let's take it out. So here I have 2 square. It looks like is the cross line here is the largest. Did you guys know how, if we told you two sides of the right triangle, how to find the third side? Anyone have this idea? If the right triangles, if this side is A, this side is B, this side is C, do you know what the relationship between them?
A squared plus B squared equals C squared.
Exactly. All right, I will talk about this a little bit more. Did you guys, anyone, how to prove this one? Anyone prove this one? Ever? How to prove it? All right. So whenever you see square, C square, B square, A square, we can, all right. So we can do what this thing need square. You can see here, if this side A, this side A, this area is A square, right? So I've used different color here. So if you see these kinds of things, this is A, this B, this C. So we know it looks like less something like this. So A square plus B square. How to make it? Let's do something different. So C square. C square, why you not make it this C square? So each side of C, right? What about A square? How we create A square? How we create A square? A square is somewhat like what? Is okay? So let's do a little bit backward. So here is the right triangle, right? So this, so we have no, whenever right triangle, any triangles, the inner angle, three of them, some of them, we suppose here is alpha, here is beta, this one is 90 degree, right? So this is 90 degree, this is alpha. Alpha plus beta equal 90 degree. So this is alpha, and this is 90 degree, so this angle will be beta, right? So looks like this is the same. So we extend it here. We find a spot, make it become right angle. So this is beta, and this is 90 degree. Looks like this is alpha, right? So this is beta again, because this is right triangle. So extend it a little bit, and we make something become right triangle here. So here is beta, and here is alpha. And extend it here again. Here is beta, and here is right triangle. What about this one? It's simply alpha. So you can see there's some interesting. So this is A, this is B, right? So this area of this triangle will be half of the A times B, right? And it looks like this is the same. This is A, and this is B. And this is A, this is B. This is A, this is A, this is B. That's four of the triangle, right? And plus this tiny square. What a tiny square? Tiny square in the middle part, right? So this is the long side B, and this is A. So what's the age of this part? B minus A. Right? This is a square, right? Plus B minus A square. And equal big square, right? Big square. Okay, so if you guys know this part, did you guys? So if this need a little bit more knowledge about algebra 1, right? So this part you do the distributed inside, you got a 2AB, right? What about this section? This area. This area will be B squared plus A squared minus 2AB. Minus 2 times of the two terms. And then equal big square, copy down this part. You can see this is disappeared because of this opposite to each other, right? So you can finally got a B squared plus A squared equals C squared. So this is a theorem. This is theorem. What's the theorem? Did you guys notice?
Pythagorean.
Exactly. Exactly. So we use these kinds of information here. This size 2 and this size 1. So what about this side? So we're supposed here that is R, okay? So 1 square plus 2 square equal R square. Right. So we go back to say what area in the square of centimeter is the largest circle. We know when a circle with the radius r, what the area would be? What is this circle area? Pi r square. Right? We use this information. This big circle, pi r square. This r square equals what? Equals 1 square plus 2 square. So we place it equal 5 pi, right? Wow, so many people get answers. So we have 16. 16. A little homework. Not talking to guys who said shit. Jason, please listen here. Don't talk in the chat. This is chat bar. It's not for your chatting. It's provide answer here. I don't like to see you guys provide too
Yeah,
much
he
talk.
was saying I was saying shut up, but I didn't.
All right. So this chat part only try to provide answers of each question. Okay, it's not for chatting. Unless you question to this question. Okay. All right. So thank you for your respect each other. Okay. And that's important. All right. Just like say we come classes, we try to help each other. It's not try to blame each other. We try to find problems, find solution for the problems. We not try to create too much problems. Okay. All right. Makes sense. So the answer is here. Oh, I didn't change it here. The answer is C. I didn't see you guys. Did you guys put answer there in the C in the chat part? Okay. All right. So the answer is C. Okay. All right. So let's a lot of information here. We have some. Firstly, let's revisit this part. So firstly, they have geometry, right? Geometry. You try to find the biggest circle, right? So this one need a little bit sense about the geometry. Second part, you need to find the radius. How you create. So based on the size of the square, based on the right triangles, how you find, if you total two sides of them, how you find the third side? Use this formula, right? A squared plus B squared equals C squared. So if you total of two of them, you can find the third side. So the third one is circle cancel area. Let's come on, that's the easy part for you. So you just need two very basic knowledge. Geometry, and you find the a squared plus b squared equals c squared, this basic theorem in here. Reasonable? Any questions? No. Please ask if you don't understand properly, okay? We need it. We need that. Make sure you understand it. Because of this one, partially will maybe sign homework again. You need to do it more independently one more time. Right? Okay. No question. We will move on next one. Right? Okay. All right. Put your answer in the chat part first now before I ask Jesse, can you help me read this one? I cannot hear you.
Sorry, my mic was off.
Okay.
Each of the even numbers 2, 4, 6 to 50 is divided by 7. The remainders are recorded. Which histogram displays the number of times each remainder occurs?
Oh, so this is like a series number. There's a lot of series number there, right? The remainder are recorded. So this is a lot of information. Each of the even number is divided by 7. So remainder are recorded. So what's the remainder potentially are? First question. So any number divided 7, what's the potentially remainder are? 1, 2, 3, 4, 5, 6, right? Less than 7. And remainder potentially 0, 2, right? Okay. So we just list the remainder here. Remainder 0, 1, 2, 3, 4, 5, 6. So what's the, so I would list here. What potentially, and something like here, you can do quickly. So if they are beginning 2, 4, 6, so already here, so beginning 1, I just like 1 little remainder. So if they bigger than 7, like 8, 10, right? 12, of course you can do all of them, but you need to find what's the big things what we to do here, because so many numbers. So we know how many total numbers. All even number is 25, right? 25, 50. They are even number. They totally have 25 numbers. 25 numbers. So you can quickly go through here. The sum of them is did they provide 25 numbers? It looks like provide 3, 4, 4, 3, 3, right? 3 times 3 plus 4 times 3, 4 times 4, 16 plus 9. Yes, 25 numbers. Yeah, you can see all are recorded 25 numbers. So the thing is we need to find a pattern. We can do a little bit into study investigation. When you go to the industry, you have to do some investigation, something like find a pattern. So 2, 4, 6, right? We go a little before. Let's go to the 20 first, or we can go to, and then you can find out this is what's it looks like, what's the potentially looks like. So you can see this is 1, 1, 1, and then this the remainder is 2, 4, 6, right? What's the remainder of this one? Is 1, right? So I will record different ways. So 2, 4, 6. And right now here became 1, 3, 5, right? And 0. Did you find the pattern? 2, 4, 6, 1, 3, 0. And what about next? Also 2, and then 14, right? And 2, 4, 6, 1, 3, 5, 0. Looks like these kinds of pattern. Do you notice that? Right? So the remainder here, 2, 4, 6 is 1, 3, 5, 0. 2, 4, 6, 1, 3, 5, 0. They cover all the 7 numbers from 0 to 6. So we just need to go to, so here, this is 7 number, this 7 number, another 7 number, another 7 number. Looks like a little bit over, right? They totally 25 numbers. Let's 7 number here, 7 number here, 7 number here. The last one only have 4 number here, right? 4 number. So the 4 number is 2, 4, 6, 1. So the rest 3, 5, 0 here only have 3. This one didn't show up again, right? Suppose have, if they continue going on 50, should be 350. If they have 28 number, something like say 52, 54, 56, that would be 350. So looks like 2, 4, 6, 1 have 4 of them. Okay, one come here, one come here, another one come here, another one come here. So you can see here 2, 4, 2, 4, 6, 1 have 4. 2, 4, 6, 1 have 4 number. Looks like it's A. I'm correct. Is I'm correct or not? So the answer is, what you guys answer? So 350. 350 only have 3. A, yeah, everyone is A. Huh. Okay. Kaiden, we found Nick, Brian all get A. What are the rest of you guys? No? Okay. So do you know what I mean? What I'm really summarize this question. So you looks like, so first we need to understand this question. So they have 2 to 50, or even number have 25 numbers, right? And then they find the remainder and then record it. What historian displays the numbers of times each remainder occurs. So I find the pattern from 2 to 14 is 246, 2461350. Like this have pattern here. And then last one, I find how many was not showed up again, this part. And then I put a record here. So easily to find out. So you can see these kinds of questions. I don't know you guys learning in your normally routine math classes do these kinds of thing or not. Normally not, right? Normally they didn't teach you this kinds of system thinking. They maybe teach you, say, how to do plus minus times and divide of the, and also variables. So this is a little bit different than our normally math classes. Just keep attention. Let's make sure you're thinking the way what I'm talking. Okay. All right. I will leave two more people. Good. You have a different way, Jesse. Can you explain? Let's be cool, Let's. All right. I will delete this part and be clearless.
Wait, so I explain my way?
Yeah, please.
Okay.
You can draw online. Do you have a notation?
Okay.
You can draw on the screen.
So basically, like the 3 here, like there's some of them have 3 in the beginning, others have 4. So I just like see how much like numbers that have like zero remainders. So
Okay.
if there's like 3, all the 4s that have 0 just be like eliminated.
Okay.
And then like just repeat like the 4s, the 6s, how many have like 6 remainder, and there's 4 6 remainders, so 3 is just the 3 here. Remainder is just like 3 of
so
6
you
is just
eliminate.
eliminated, just like leave, just like elimination basically.
Okay. Makes sense. And then you have final AB. So how you get rid of B?
Same way, but like it's like the 3 remainder.
Yeah, so the difference between here is the number 4, right? Number 3 and number 4.
Yeah.
So you need to find out how many 3, how many 4, right? So still, but basically you still needed to do each to find out all the 25 numbers and then find the remainder, you find the answer here, right? I think your method is also works, just like which more thinking more system, because you try to find out all, you can eliminate these kinds of answers. But if they didn't provide these kinds of A, B, C, D options, when you ask you to list out 1, 2, 3, 4, 0 to 6, how many remainder left behind? So let you write out. So the previous method that I provided maybe a little bit more reasonable, right? But if you, of course, you can do the elimination method if you didn't find a very, just sometimes have way much better because they provide options, answers. You can use your strict kinds of special skills to get answers, right? Make sense? Good. All right. Nick, you do the same thing? Hey, you guys have a, by the way, Maybe a better way. Yes, you are definitely a smart guy, have to do smart things. Okay, let's move on. Number 14. Put the answer in the chat part first. I would let Caden. Caden, can you help me read this question?
A number n is inserted into the list 2, 6, 7, 7, 24, 28. The mean is now twice as great as the median. What is n?
Okay, so number, actually, let's show words he show up here. Let me read this question one more time. A number n is inserted into the list. Now, the list here 1, 2, 3, 4, 5, right? Inserted between 6 numbers. When there's a 6 number, there's 5 number, right? And let's odd number, let's even numbers. And also this is totally is only 5 number. So let's some other words called mean. Mean. And is now twice as great as the median. All right. So first, if I say mean and median, do you guys have this idea? What's the mean? What's the median? What's the mode? Anyone have these ideas? What that means? Let me give a quick kind of list. Some use a different list. So suppose like 1, 2, 3, 4, 5. I seriously 6. Let's use the 5 numbers. Okay, 5 numbers. So median number is middle number, right? Middle number. So something like you have the 5 numbers. Median is 3. What about is 1, 2, 3, 4, 5, 6 numbers? What's the median number? Actually, they have 2 median numbers, right? So it looks like a median is 3.5. All right. The median is the middle number. If they have even number, is average of the 2. What's the mean? Mean means average. What's mean? Mean is middle number, right? Median means is average. So it means one right here also equals 3. Mean means average. So if I 5 number, you sum of them and then divide the whole numbers, right? What's the more number? So some series number, you can see this series number is 7 show twice. If the most frequent number is the more number, like here is 7. But here, this more number didn't used in this question. But just like give you a basic meaning means mean, median, what it actually means. Okay, all right, so I clear the screen first. So let a number n was inserted inside. I don't know where insert it potentially. The thing is you can insert here any position, right? But you cannot insert in between here, right? You cannot insert in between here. You can insert from here, insert from here. Looks like you cannot insert here neither because 6 and 7 is continuously. Make sense? So let me rewrite it here. So what potentially n can insert to? They can insert here. Let me use this kind of, or they can insert here, not here, not here, right? And then can insert number here, or insert number here. So if they insert number, suppose so let's find out here. So if I insert a number here, the mean number, just like I say mean number, we suppose here number, we know is average. So here is sum of them divided 5, right? So here is 8 plus 14, 22. 22 plus 28 is 50. So 50, right, is 10. So for kernel list theory, mean number is 10. What's the median? Median is middle number. So in 5 number, the median is 7. So in current 5 number series, the mean number is 10. And then median number is 7. If they inserted right now is twice, it's bigger. So it means mean number is bigger than 10. So if add a number, so this one is not twice of this one. So if they are bigger, so you need to be inserted here or here. You cannot insert small number, right? If you use small number less than 10, what it looks like? It's being even smaller, right? Because if you insert smaller here, the middle number is still 7, right? So here, median number, something like insert here, 1, 2, 3 number, 1, 2, 3 number, so median number is 65.5. So even smaller. So it looks like have to insert somewhere here, right? You need a bigger. If you need a mean number bigger, if you insert between here, yes, you can say X between here. So I let me clear the screen here. Partially off the screen. So it's not insert here, cannot insert here, cannot insert here, only can insert some number here or here. That's two situation, right? So I suppose here, so suppose A situation, I suppose here is A, the X here. So this number is in between 7 and 28. So I have 6 number, right? So what's the mean number? Mean is 50. So initially here is 50, right? Plus X divided 6 equals, what's the median? Median is 7 because here 7, 7. So it's 2 times 7, right? So if I insert here, the mean is this number, the median is 7, and then they are twice of them. So we need to find these solutions. So here is 14 times 6, right? It's 84, right? So 50 plus X equal 84, X equal 24, 34. Sorry. So 34 is not met this equation. Cannot here. 34 is not inside X34 should be put it right here. Right? Okay, so it's 34 makes sense. If you put a there 34, oh, works. So the answer is 34. What do you guys answer? Oh my gosh, so many people provide answers. Yeah, E is mode. Jason, you got a E. Oh, class ends. Ryan, why you answer that question? We end the A40. Okay, so, all right. So by adding all numbers divided by the amount added. Mean is the middle number. Yeah. Median is the middle. 7 is the mode. Good. So let's suppose thinking, average thinking here. I mean, several thinkings. This is less. You can find out here. We began to use some variables. Began to use some basic geometry, algebra. Did you guys make sense? Did you find any questions? Anyone have different answers? All you guys have the same answer with me? Please correct me if I'm wrong, okay? Sometimes I make mistake, I told ya. Okay, nobody. I will move on next one. If you're not. All right, let's more thinkings. So when you go some different questions, it's a lot of fun part. Okay, I will let one of you guys put the answer here. Waveform. Can you help me read this question?
Kai draws
And
a 6x6 grid. He colors 13 of the unit squares silver and the remaining squares gold. Kai then folds the grid in half vertically, forming pairs of overlapping unit squares. Let M and M equal the least and greatest possible number of gold on gold pairs, respectively. What is the value of M plus M?
oh, that question is pretty long. Thank you, we found. Okay, you guys, a lot of you guys put answers there, also chat there. I don't think we have 11 people here put 11 answer there, but let's go through this one. So thank you, we found. So 6 by 6, how many total numbers square here? 36 squares, right? So they cut, they color 13 of the squares silver, we could say S, and then the remainder is golden. So 13 silver. How many golden? 23, right? Makes sense? So answer the first question. 6 by 6, color 13 silver, and then the remaining golden, 23. Okay, then fold the grid in half vertically, half vertically. So how many is in this side and how many this side? 18 this side, right? I use different colors. 18 this side, 18 this side. All right. So, so, so you have here, you have 18 this side, 18 this side. You have 13 silver, you have 23 gold, right? Welcome, Andrew. And you can see here. So you have color this side, this total 36. So cut half, 18, 18. Let the M and big M, capital M, equals the least of the greatest possible match of golden, golden. Okay, golden, golden. You have 23. If I color all here 18 golden and color how many here? These are 5 side here, right? 1, 2, 3, 4, 5. So you can see if I color this all golden, this side 13 all gold, 18 all golden, the rest 5 will be here. And then you can flip over only these 5 match, right? It makes sense. If I color here 18 golden and only 5, the rest 13 is actually silver. So only these 5 can match this side 5. The rest is silver and match the golden, they are not count. So only 5. So M1. If I color this all golden, right? So only 5. M it can be 5. The minimum 5. Okay, so capital. So if you say want to best match, so I try to split the biggest value, the gold, the least and the greatest number. So you can see, these 5 already match. So I try to average half here together, right? And then put the kinds of symmetric position. So you have 23. Why not say I put a 12 here? I use 6. I use 6 here. I use 6 here and used 5 here, right? You use 6 first 6, you can all match up. Use this 6 and use here 5, right? Totally 23. Makes sense? So the rest colored silver. So at least 11 of them can match. Right? I mean, 6 match and 5 match, totally 11 match. So small m, capital M, I got 16. Did you guys got 16 or different answer? Oh, yeah. Thank you, guys. You see, I match yours. I just wonder if I match yours. C or E. Jesse, you got E? Oh, oh, you deleted C. Good, good. So basically, actually, you need thinking through these kinds of question, right? Try to see what kinds, what's the potentially match or minimize match. So the more something like say the less part. So make sure all the silver match the gold and the rest match. So actually something like 13 and 13 they are match 13. The rest is 10 left as 5 match, right? If you say maximum, so if this one you need to split it, so 12 and 11 of them match, yes, 11. Actually, some of them easy thinking better than what I'm talking about. So you're gonna got a 5 and 11 much quicker than what I thought. Anyone have different way get quicker answers? Please speak teachers, right? If you have better way and easy way than what I'm talking, I really welcome you guys to talk to me to make it quicker. Oh, you have better quick tricks, methods, make it quicker. Please share with us. So the answer is 16 here. Let me see, you guys, anything different? 3 new. Mine was slower. Oh, maybe you have different, more system thinking. No. Oh, it's no worry, Jesse. Don't say slower. We just say different methods first, and then you compare the two. Different people thinking different way. Maybe your way is better than what I'm thinking, but you say slower. Maybe in that moment you are faster. I do this multi times, so I can find this way is quicker. But at the moment, at the first time when I read this question, I maybe take even longer time than what you're thinking. So don't compare kind of thing. Just like say how you find the answer more logically, right? More logically, more understand, more easy to explanation to different people. So someone asks if you give you the same question. So if you can explain it, make it understandable for everyone, especially for someone have limited knowledge. I'm older, I'm teacher, learn much more than what you think. Maybe think different way, a little bit faster. But if you can explain someone have limited math knowledge, you can use the very understandable kinds of methods to explain it. That's the coolest part because you understand it, you can explain it properly. Oh, that's the best way because it just to be honest, for you, if you have a good way to explain your methods, you really master the methods. If you didn't explain clearly, you need to rethink about it. Some pieces potentially missing. So that's why I like to provide the answer to you guys, let you have enough time thinking about it. And then revisit. So make sure whenever you do one question, you understand it. And then next time you do it, hey, I do this question again. I know the same pattern kinds of way to thinking. So you can do way much better if you near future go to AMC8 kinds of math competition. So you need to practice this. And something just like say, we earlier say they have 40 to maybe less than 40 or 15 minutes to finish 25 questions. So you can see each question have less than 2 minutes. So you need to do pretty fast, right? You need to read the questions. You need to quickly draft down. You cannot base on thinking, right? You have to use some draft methods to make you thinking translated into math language and then do it properly and make you understand. You don't have to remind too much pieces in your mind. You can just draft down and then do the work. Make sense? Okay, so the question of the homework part is done. Let's move on a little bit new topic. Okay, I'm sorry, back forth here. So today I will talk some new topics. Okay, remember, so this is module 1 of the AMC is big chapter. It's one of the 4 chapter number theory. Is very interesting. Partially maybe we already talked. All right, partially we already talked, but we potentially duplicate. But I try to avoid it. All right, let's go to this part, primers. Anyone have definition of primers? So primers only have 2 factors. One is number 1 and itself Of course, both of them are non-negative. All of them is positive factor. There are only two factor. One is 1, and the other one is itself. We call primer. So first thing, can you list all primers less than 100? Anyone can list. So I will let someone say partially of them, okay? So Brian, you first. List all the prime number less than 10. Talk it quickly, okay? What a prime
Under 10?
less than 10. What kinds of number?
1,
Quickly.
2, 3,
1 is not.
5.
1 is not primer. 1 is not primer. It's only one number, 1 and 1. So this one is not primer, okay?
Okay, then 2, 3, 5, 7, and 9.
Are you sure 9? 9 can 3 times 3, right? So 9 is not. 10 is not neither. So only 2, 3, 5, 7. So you can see all the even numbers can something like 4 and 6. These even numbers, they can divide by 2, right? So they are not counted. They are not, right? Because they have 1, 2, 4, right? You can divide by 2. It has more than 2 factors. So they are not. All right. So Jason, list all the primer between 10 and 20. I will assign you guys do it. So someone list here. Anyone? Jason, you do this part.
11?
Jesse, yes, Jesse, you can just write on the screen if you like.
Me?
Okay.
And
Okay.
waveform, you list between 30 to
So
40.
11. 11.
Wait, do I do it?
Oh no, list here. Don't read
Oh.
somewhere else. List in between here. Waveform. And
Okay.
then Clayton.
Oh, but I
list
can't draw on here. My drawing shows as buns.
It's fine. Readable is okay.
Oh my god.
Brian, you do one more, can you? That's between 50 and 60.
So 11, 13,
This is 80.
13, 17.
From what do I do it from 10 to 20?
Yeah, please pick one. Or you
19.
can pick some bottom part. Between less than 90 and 100. We need to list all in out. Yeah, Nick, I'm sorry. I need to put this one inside charge a little bit.
Should I do the 20s too?
Yeah, you can do them all. Yeah.
Okay, 19, 23.
Or use different colors.
Okay.
Brian, you do this one, Brian.
23. 23, and 27. I mean, no, not 27. And 29.
Yep. What about 37? I mean, here, we found you list different kinds of location. Below 40, man, we found. Kaden, you write below 50.
Oof.
Brian, you say between 50 to 60, not 61. Everyone know a different line. Oh gosh. We find less than 40. What about?
Oh my gosh. Chaos.
Okay. Brian, 51 is wrong, okay? So
wait, why is 51 wrong?
Why? Yeah, good question. 51 is what times 51?
3.
5 plus 1.
3.
Oh yeah.
What? Uh-oh. Yeah, I will told the rule. So basically, you guys very good. You guys, what about 91 is correct or not? 91, yes or no?
No.
No.
Yeah, is
7.
17 times 3, right? No.
Or 7 times 13.
Yes, exactly. Good. Yeah, 91 is
Why
not.
did mine just like all get deleted? Why is it so hard to draw?
Oh yeah, use the mouse. If you don't have, you don't touch screen. If you use iPad, it should be easy. If you use the
I
something
don't have
else,
touchscreen.
oh no, you better you ask your mom use the iPad. iPad is touch screen, right? So you
I
can
forgot
easily.
my iPad's password.
Ha! Oh my gosh! So how you access to? Maybe reset. Go to the Apple Store, ask reset. Okay, all right. Let's stop here. So let's check them first. I will use the super big red to judge you guys. Okay.
No.
Okay. So let me quick check. So first one here and 11, 13, 17, 19. So you can see less other than 2. No even number should be show up here, right? So first thing. Second thing, all numbers, if each of the digit, just like 51, right? If each of the digit, some of them, like here is 6, is this number can divide 3, they should have the factor 3. Make sense? So 51, that's why 51 is not. Because of 51 can be 17 times 3, right? So 51, you have 1, 3, 17, 17, and 51, right? So any number, let's find number here. So let's one. Let's no even number. Okay, what about 80? I think what's this 89 or 84? Okay, you guys can find this. This is 89.
89. 89. I wrote it on the
89,
bottom.
89. Good. Yeah. So if you say 84, I will eliminate it quickly because this should not show up this number. Okay. All right. So 91. Some of the special numbers, some 13 times 7. This is not easy to try. Sometimes they are odd number, but the sum of them is not like 10 is not 3 times. So not easy to judge. So it's some special number. You need to be careful. Remember that. Okay. All right. So good. Thank you so much. So write down. So basically, what I'm teaching here actually not only teach you prime part. I just let you try to find out which number can divisible if they are divisible by prime number. So basically, so how you that's pretty decent. So everyone do excellent job. Okay. So I will be let you guys. I will provide these answers. So if you can you guys provide any number, prime number in between 100 and 200? I try to let this part in your homework. But I just provide you quickly here. You can judge it here. You can see here all the number. I will clean screen one more time, okay? Because I believe you guys can do prime number properly since you guys 5th to 8th grade. Majority of you guys is 6, 7, 8th grade. So this is very common part. All right, I will clear the drawing. Okay, so
Is
oh,
zero
what's here?
prime or not?
Oh yeah. So
Zero is technically even, I think.
yeah, 0 is not counting because 0 is not divisible by just like because of they cannot not factor 0. All right, 0 not count. So at least minimum 1 in itself. You can see the bottom part
Okay.
here. A prime number is a natural number. So first, a natural number should be positive, right? Greater than 1. It has no positive divisors other than 1 in itself. So you can see the bottom part here. Make sense? Makes sense? So prime number actually is here. We define it's a natural number. Also need to be greater than 1, has no positive divisors other than 1 in itself. So some confusion sometimes is something like this number 199. Hey, can divide by 3. So I will move on second kinds of big rules talk about here. Okay. All right. So let me go next page. So list part. Please go home to list all the prime numbers between 100 and 200. I give you a region here first. Something like 101, 103, 107, 109, 113, and something 127. Think about these numbers. When these numbers show up, you can quickly see if they have divisible, they can divide prime number. Sometimes number is too big, something like say 91. Because of their number is so big, it's not easy to judge. Right? So 91. So some special number is both of the factor is big prime number. So it make you a little bit challenging to decide, hey, it is something like 13 times 11, right? So all big numbers. So will be what? Something like this number. Looks like prime, but sometimes they have big prime numbers. So not easy to remember well. Okay, so how we judge the kinds of if they are divisible? So first thing, if they can divide by 2, the last digit number should be even. Right? Make sense? Make sense? Right? If you divisible by 2, last digit should be even. So like this any. So this one obviously yes, this one is not, right? So how to judge a number can divide by 3? Sum of digits is divisible by 3. So anyone can judge here. Is this number divided by 3? So you can just quickly, you don't necessarily do this way. A lot of people do this way. Sometimes you can say 2, 3, yes, and divide, right? You can 3 and 2 and 12, 12, and then 3, 2, 6. So it means 392 can be 3 times 326. Of course, divide. But some tricky way, you can see do each of the digit number. Some of them here is right. 16 plus 2 is 18 3 times. This 18 can still divide by 3. So they can divide by 3. That's easy judge. All right, let's number this rule. Divided by the rule divided by 4. If they can divide by 4, definitely the last digit definitely should be what? Should be let should be even number, but you don't necessarily something like you don't necessarily judge too much. You can judge only last 2-digit number. Last 2-digit number. All right, let's quickly see number. Something like 100, right? So definitely divide by 4, by 24 by 25. You see last 2-digit number can be divided by 4. Or you can say 156. You don't necessarily care about this number. Why? Because 100, any number, last top part is hundreds, right? Hundreds. Hundreds definitely divisible by 4. You just need to care about the last 2 digits, like 56 should be 14 times 4, right? So you can judge by here. Last 2 digits can be divisible by 4. But what about this one divided by 5? And you just need the last digit number is 5 or 0. Makes sense, right? What about can divisible by 6? Divisible by 6. So divisible by 6 means they can divisible by 2 and divisible by 3. So you need to apply both rules here. 2 of the rule here. So if you can divide by 6, you have to divide it by 3 and divide it by 2. So if you by 2, so first you need an even number. Second one, you make sure each of digits plus them together, sum of them together, should be divided by 3. Like here, yes. What about this one? So you can say 5, 2, 6, 11, right? They cannot divide by 3. So of course, this one cannot divide by 6. Even they are even number, but they cannot divide by 6. Make sense? Divided by 7. This is tricky one. Just like say, you have to take the factor 7 out until you find the smallest number is divisible by 7 or not. Is that 0 or not? The remainder, find out remainder. Like 91, yes. You divide by 7. So 1, 21, 3, yes. So it's 91. You take this factor out, the rest still a whole number, right? Or you can say divided by 7, but you don't necessarily do this part. So it's still a whole number. So they are divisible. So this is one a little bit tricky, divided by 7. Okay, let's go a little bit more. So any number can divide by 8. So divided by 8, we know. So here's a last 3 digits. Last 3 digits should be divisible by 8. Because what? So something like 1,000. Anyone, did we guys know 1,000 equals 8 times 125, right?
Yeah.
Yeah.
So it makes sense. So any numbers, something like say 1,256, you don't care about this part because this part can be divisible by 8 already. So you just need to care about this part. So this part divided by 8, basically, it should be even number definitely. You can divisible by 4, divided by 8. So any these factor should be applied here. So you can just like say this part. So you can eliminate it here. So you can divide 8. So here is 3 and 2, right? 24. So it's good. It's reasonable, can be divided by 8. What about divisible by 9? Sum of digits divisible by 9. Same like the 3 rule, right? Divisible by 10, last digit should be 0. So this is very common. Any number, so very easy. So what about divisible by 11? This is tricky. So we can see here, sum of odd position digits, even position divisions, if O minus E is divisible by 11. That's interesting. This is very, very tricky part. 11. So give me one example, 121. So if you do normally kinds of way, you can say here is 1, and the left 11, and 1. So 11 square, we know 11 square equals 121, right? That makes sense. So let's use this rule. Let's check this rule. Odd position just like this one and this one, right? Sum of them O, so O equals what? Equals 2. So O equal 2. Even position is 2. So E also equals 2. So O minus E equals 0. So 0 divided 11 or equal 0. Yes, so that's why it's what? That's why this rule makes sense, right? So let me find another kind of big number. So you can see, what about this number? 1331. So odd position is 3, and you can see here is 4, right? The O is 4. So E is also 4. So minus is 0. So they are divisible by 11. So let's use the routine rule. Just like use the routine rule so divide 11. So you can use the 1. So it's left 2. 23. You use 2. 22 is 11. So 1331 actually is 11 times 121. It's divisible by 11. The rule makes sense, right? So what about 134? Let's see 134. So odd number, the sum of them is 5. And E is the even position number is 3. So difference of them is 2. 2 cannot divide by 11. So this one cannot divisible by 11. Let's triple check it. So if we divide 11, 134. Let me clear screen it a little bit. So 134, if you divide 11, right? So you can use 1, 11, 24. You use 2, you left over 2, right? So it's not divisible by 11. That makes sense. So the rest is the same rule here. So if you find divisible by 12, you have to divide it by 3, by 4 at the same time. If you divide it by 15, you need to divide by 3 and by 5. So the same kinds of rule. Only thing just like you need to remember 11 and number 7. That's too typical. A little bit challenging, but you need to remember, just like I said, more practice. But all right, let's move on a little bit more. So let's rule. I will give you guys some of the this PowerPoint. Okay, so let's find a fraction called factorization. Can you guys help me factor 117? What kinds of prime factor in a factor? How you guys did it? So 11, 11, 7. So you can quickly, this is our number, right? It cannot divide by 2. What about by 3? 117. Some of them is 9. So definitely can be 3, right? So you can divide it by 3. What's the next? So you can do here 3 times 9, 27, 9, 39, right? So 39 still can times 3 and times 13. Make sense? So you can see 117 actually you can do 3 times 3 times 13. Okay, so what's the prime? What's the factor potential you have? You can list all the potentially factors. 1, 3, 9, and 39, right? What else? Oh, we missed 13. I forgot, right? 13. So what the rest? The rest, 1, 1, 11, right? Make sense? Makes sense. So have 1, 2, 3, 4, 5, 6. Have 6 factors. Is it correct? Do I miss something? Anyone? Did I miss something? Brian, did I miss something? Wei Fang, Andrew, I'm sorry, you may be a little bit later, but I take a video. So did you guys miss something? So how you find this number 6? If I give you a number, say how many factor here? So you will need to list all them out, do the count, and then 6. All right, let's do some quick examples. So 100. So can you guys do the factor list 100? 100 actually you can do. So definitely you can have take 2 out, right? So most people do this way. So you get this all number, you take 2 first, 11, 50. Oh, it's still all number, take 2, another 2 out. Let me use my pen. Sorry, when my pen is out of battery, I back charge. Listen to how better it works. Let me do this way. Do you guys have me factor 100? So
Okay.
100. Oh yeah, it works now. So you can take at least 2 out. You can say got a 50, right? You can take another 2 out, got 25. So right now you can say 5, 5. So 100 actually can rewrite into, yeah, Jesse, 2 times 2 times 5.
Could you like speak a little slower?
Yeah, sure. Speak slower. Yeah, sure.
Yeah.
So
Thank you.
100. So when you do the factor, most of the time, just like we try to observe it, if they are odd number, right, you can just take 2 first, take 2 out first. So you can take another 2 out, you get a 25. And then 25, you take, of course, end of 5, like divisible by 5. So just like say 100, you can rewrite like this, right? All right. So my question is, can you list all the factors of 100? So definitely is 1, definitely 100, right? Definitely 2, you can 50, right? Definitely 4 and 25. Did I list all? Did I miss something? What about 10? What about 20? Right? What about 5? 5 times 20, 10 times 10, right? All right, let's count how many number here, how many factor here. 1, 2, 3. So actually, like a pair, right? Pair. Is it a pair? You can see here. Each
Yeah.
and 10 is 10 times 10. So how many total number here?
8.
1, 2, 3, 4. Totally have 9, right? 9. In near future, I will talk to say. So this one, you have 6 plot. You have 6 factors. Where does 6 come from? Right? So this one you can see times 3 times 3 times 13. So I don't know you guys have ever write like this way. So 3 times 3, you can 3 square times 13. My charger here is not working properly. Let's got a full charged. So you can write this one. The same here, 100, you can rewrite like this. 2 square times 5 square. Right? Is it correct? Yeah. Okay. So you can see quickly to see if how many point number here. I mean, how many factor here? How many factor here? So let's quick way to find factor, right? So basically, I don't know that you guys use this rule or not, but I often use this method, quick method to find a factorization. All right, let's do one more, two more of before we finish today's canceling. Let's do number 6 and do to list these slides, the 2 questions in 2 slides.
I have to go.
You have to go? Okay, if you can leave it, I will recording so you can see, go back to visit the video later. All right.
Thank you.
Sounds
Bye.
good. Yeah, definitely. Talk later. So I want to look this one first. Let Z is a 6-digit positive number, integer, such as 247, 247, whose first 3 number is the same as its last 3 numbers. Okay. And then 3-digit number taking the same order, which of the following number must be also a factors of Z. So Z. So we don't know. So this is just a example. So you can say suppose number is ABC, ABC. So each position is 1-digit number, right? 6-digit number, and the first 3 and the last 3, right? So if I take a ABC out, looks like I can take ABC out. And then time, what's this number? 1001, right? Can we? So 101, 101. All right. So at least Z, this Z, have one of the factor is 1001. 1001 can be divided by what? Did you guys have any idea? Let's check. They cannot divide by 2. They cannot divide by 3, right? They are odd number. They are not, some of these 4 numbers is not 3 times, not divisible by 3. But we'll find out. If later 13, something like 1001, did you guys can find any factor number here? What about 13?
11.
13 times 11, right? So
No,
13, you
11.
can see. Oh, it can be divided by 11?
Yeah, 91.
Yes, exactly. Yeah, you can 11. So 91, 13. So looks like 101 can be equals to I give up this use this pen because of their charge didn't have enough. So this one I will it will be 13 times you are right. This one can divide by 11, right? And 7. Is it correct? You can judge it. 3 times
Yeah.
1 times 7. Yeah. So they use the big prime number and then plus of that. So you can see here, they can be divisible by 11. This is not right. This is not right. Right. This is not right.
19. That's not right.
Yeah. So sometimes just like this one, need to remember 101. Actually, it's not prime number. They have three different kinds of prime product. All right. So let's stop here. So I will leave this question, last question, as as a homework. Let you guys finish the rest, and then let me come back with this homework later next time. Just like remember, this week we just a small summarize here. So we learned the question from 11 to 15. I will continue assign 16 to 20 question from 2025 as homework as well. And the rest of this part, I think that's maybe only two or more slides. I don't like to you guys do too much, spend too much time here, but just practice, okay? Maybe before these factors, all right? So before this part, before the 102, I will assign 1, 2, 3. This majority of this question actually come from AMC previous test from the 1985 to 2024. Okay, so the question is come out. You can see that this kinds of math question is not basically thinking a way you are learning in the journally math classes, a little bit different. All right, sounds good. Let me see what you got left in the questions. Oh, guys, you sound do very good. Excellent, guys, and I like to see you guys continuously next week. Okay, and if you're interested, just register the classes. If you like to talk to me personally, more question, personal question, just give me a call or leave a message. Let your mom leave me a message, and we can set up a small kinds of one-to-one to explain your questions. Sounds good. All right, so that's done for today. I don't like to delay too much. Make sure you guys have enough sleep for tomorrow class. Talk to you later,
Bye-bye.
guys. See you later.
6
Good night. Good night, guys. Talk to you later.